In this introductory demo, I would like to show you some of the time series analysis capabilities of Econometrics Toolbox. Here you can see a list of selected features of the toolbox. I will demonstrate some of these features through an example of modeling the Nasdaq index data. As you can see in my workspace, I have already imported the data into Matlab. You can import data from files and databases stored on your computer or directly from numerous financial data providers using our data feed toolbox. I can plot the data simply by selecting the variable and clicking here, or by using the functions subplot and plot, as you can see in my script. Now let's say I would like to see if this data is stationary. Econometrics Toolbox has some stationary tests including Dickey-Fuller and Philip-Perron unit root tests. Let's say I want to perform a Dickey-Fuller unit root test, but I do not know the name of the function in Matlab. I can go to the function browser in the command window, where I see a list of all the toolboxes I have installed on my computer. I go to Econometrics Toolbox and I see the subsections under Econometrics Toolbox, and this function should be under Statistics and Tests. The BIC function, Arch Test, Autocorrelation, Cross-Core, and here we have the Augmented Dickey-Fuller test. I can read about it here, or I can click here for more information. Or I could just click on the name of the function to have it typed in my command window. Now I want to perform the test on Nasdaq data. And I see that it returns 0, meaning that the null hypothesis is not rejected. The null hypothesis is that the characteristic polynomial of the data has a unit root. So the test result tells us that the data is not stationary with the default significance level of 5%. Now I will go back to my script and calculate the return series using the function price to return. And I plot the data. I performed the same Dickey-Fuller unit root test on the return data, and I see that the output is 1, meaning that the null hypothesis of presence of a unit root is rejected and the data is stationary. So I will continue my modeling on the return series. Next step, I'll try to investigate the autocorrelation in the data. I use the functions autocor and parcor to calculate and plot autocorrelation and partial autocorrelation of the data. In these plots, I see that obviously every data point is completely correlated with itself, but no significant correlation exists between data at time t and the lagging data. This suggests that I do not need any moving average or autoregressive terms in my conditional mean model. Now I will calculate and plot the same for the squared returns. In this plot, we see considerable correlation in the data, suggesting the need for a conditional variance model with moving average and autoregressive terms. We can use tools like Young-Box-Pierce test and Engel's arch test to quantify this concept. Here I have used the arch test function. In the command window, you see that the function output is equal to 1, meaning the null hypothesis of lack of Garch effects is rejected. So I'll go ahead and create a Garch 1-1 model using the Garch set function. You can choose Gaussian or t-distribution for the innovations, and the options for the variance model are Garch, eGarch, and GJR. In the command window, you can see the model specifications, and then I will fit the model parameters to the data using GARCH_fit function and display the results using GARCH_disp. Now in the command window you can see the value of the estimated parameters and the standard errors of the estimation. Here the choice of a GARCH11 model was arbitrary. One could use Akaike and Bayesian information criteria or likelihood ratio test functions to compare different models like a GARCH11 and GARCH21 and select the appropriate model. Now that we have our model fit to the data, we can use functions GARCH_pred to forecast the future mean and conditional standard deviations, or we can use GARCH_sim to create simulation paths based on our model. For more information on Econometrics Toolbox, please visit the Econometrics product page at www.mathworks.com, where you can find the datasheet, additional demos and webinars, the list of the functions in the toolbox, or obtain a free trial version of the software.